Greeting to the lecturers. We are from Group 1 presenting our group project, Drug Identification System. So now for the introduction. Drug identification plays an important role in forensic investigations and law enforcement. However, traditional drug analysis relies heavily on experienced forensic chemists. Several challenges exist, such as the loss of expert knowledge when senior chemists retire, and high workload of manual analysis and delays caused by laboratory backlogs. To address these issues, we developed a drug identification system using C-Labs. The objectives were to create a knowledge base for common drugs found in Malaysia, develop a forward-chaining interference system, and automatically generate identification reports. Moving on to data collection and facts, the knowledge used in this project was collected through interviews with a senior forensic chemist from Jabatan Kimia Malaysia who has 33 years of experience. Important information gathered included common drug categories found in Malaysia and standard laboratory procedures used for identification. The testing process consists of 3 stages: physical observation of the sample, chemical color testing, and instrumental analysis using GCMS and GCFID to confirm the drug and determine its purity.
And then we're going to talk about methodology, telegraph, and forward chaining. So first, methodology, we first ask the expert to give information about the drug, how the tests that have to do, and how it's been observed. And then we analyze the information to separate it by the rules, and then we generate a C-Lab program to make our knowledge base system. So our system will use forward chaining, which will start the program with the user input, and then it will go step by step for each drug, so it can be identified specifically, and it will produce the final drug identification. And then we're going to talk about the tree graph. So the first thing first will be the physical observation. Either it will be powder, crystal, or tablet, which indicates it will be a stimulant or opioid screening or opioid drug. And either it will be plant material, which indicates that it will be a cannabis drug type. So after that, we're gonna go to the first screening test. First screening test, which will be a Marquis test for stimulant or opioid drug. It can be ATS or heroin, or it can be either. It depends on the sample. And also the screening test for cannabis, which will be a purple color that will suspect it is the cannabis. Two notes, cannabis only have one screening test, and the ATS and heroin will be two tests. So the second test for ATS is Simon's test, which indicates that it will suspect it will be methamphetamine or amphetamine, and Mecker's test, which it will indicate it is MDMA or heroin. So after that, we will go to GC, retention time, which indicate suspect that we will confirm that the drug will be ATS, opioid, and cannabis, depends on the retention time. And after all those, we will go to the MS mass spectrum that measure on MZ. It will identify the specific drug based on the group. For example, it will go to 6-mem or THC. So this is some of the result. For example, sample 101 can be methamphetamine, sample 202 can be THS, which is a cannabis type, and sample 303 that can be a heroin. It will successfully follow the expedition making steps, and it will accurately identify drug using the stored rules. It will reduce dependence on manual reference checking and improve consistency and efficiency. For specific inputs, it will be demonstrated by my friend Azam later. So in conclusion, the system will successfully develop CLIPS-based drug identification system, captures expert forensic knowledge in a reusable form, provide faster and more consistent identification, and can be expanded to detect new emerging drug in the future.
Hi, my name is Mohamad Azam Ridzuan, and today I would like to put a demo of our drug identification system using a CLIPS program. So, to start, we put the reset keyword to trigger the defect. Then, we put the start keyword to trigger the start function to ask an input from the user. So here, it asks for the sample ID. So the user will put the sample ID. For example, here we put as a 101. Then it asks for the physical form of that sample. We put it as a powder, and from that it trigger a rules which is micros test. To ask for the output of the micros test, here we put an orange color as an output. Then trigger the rules to ask for assignments color. Here we put it as a blue. Alright. Then it asks for the retention time stage. Here we put it 5 minutes, and the mass spectrum is 149. Then show the final lab report. Here it show the sample ID is 101. The drug, you can identify the drug name is methamphetamine with a category of ATS. Detection time is 5 minutes and MS reading is 159. Next we will do for the second sample, same start keyword to trigger the input function from the user. Here we use the sample ID 202, and for the physical form we put it in material. It will trigger the rules to ask for a dequinous Levine test, the output of it. So here we put a purple color. Then it asks for the detection time. Put it as a 22 minutes, and the mass spectrum is 314. Show the final lab report. Sample ID 202. Drug is THC with a category of cannabis. Detection time 22 minutes, and the MS reading 314. System here, you see the facts and also the rules for our system. 16 rules, 13 facts, 3 templates for our system. That's all from now. Thank you.